Okay, hello. Let's look at section 5.1, day 1, where we're going to mainly focus on integer exponents. And let's see if we can get the pen working here. All right, we're rolling. We are going to go through the rules for exponents. We have covered these earlier in the year, so this is going to look pretty familiar, I have a feeling. Remember your product rule? If I have two bases that are the same, I add their exponents. For quotient rule, if I have two bases that are being divided, I can subtract their exponents. The zero exponent rule, if I have a base raised to 0, the answer is 1. Negative exponents, we know move the base and power to the below spot, so I get 1 over. If it were in an underneath spot with a negative, then it moves to the top and becomes just a to the n. If I have a power raised to another power, that's when we multiply. And it also can distribute back. That's what this is indicating, that rule. And then if I had a quotient like this, we could distribute the m to the top and the bottom, giving us a result of a to the m over b to the m. And, we talked about this one. If I had a negative in the denominator for an exponent, I would move it to the top, and so forth. So that's just a quick review on exponents. Applying the rules, so we have two bases that are the same. We're going to add those exponents, giving us m to the 14th. Here, the bases are different. I can't do anything. That is the answer. So this is final answer. Cannot simplify any further. C, I would probably do some rearranging of the order of my multiplication as shown, and just reordering it into -5 times -9, p to the 4th, p to the 5th, giving us a result of positive 45, and then let's add those exponents, so we get 45 p to the 9th. Same thing on D, let's reorder all those products that are happening here. So I'd have -3 times a 7, get the x's laid next to each other, x squared times x to the 1st, so I'm grabbing those. And then I've got a y to the 3rd, y to the 4th. And then it becomes a little bit probably easier for your brain to work through it. -3 times 7 makes -21. This has a power of 1, the understood invisible 1 there. 2 plus 1, and then I'd have a y of 3 plus 4, giving us a final result of -21, x to the 3rd, y to the 7th. This one really focuses in on the zero exponent rule. We know that typically anything raised to the 0 is 1. The only thing you have to be careful about is where these parentheses are situated. So 29 to the 0, that definitely is 1. -29 is within the parentheses, so all of that's raised to the 0. That will result in 1. B is different than C because you notice there is no parentheses on this one. So essentially what gets raised to the 0 is simply the 29. So the outside negative is still going to be present, and then I would get 1. So our final answer on this one is going to be -1. That's always tricky. That's a tricky one. For this one, I'm going to have 8 to the 0, 15 to the 0 is 1, and we have the negative in between them. So 1 minus 1 equals 0. This one focuses on that negative exponent rule. So if I have a to the negative n, it becomes 1 over a to the n. So just like the rule we just talked about, this will equal 1 over 6 to the positive 5. This negative 4, well, let's not even talk about that. Let's just move it as 1 over, keep my parenthesis, 2x raised to the positive 4. And then we can distribute, in a sense, and I get 2 to the 4th, x to the 4th. 2 to the 4th happens to be 16, so this would simplify into 1 over 16 x to the 4th. On letter C, the only thing to the negative 4 power is p. So I'm going to keep the negative 7 as a numerator, and the p with the negative exponent shifts to the bottom. Don't take the negative 7 down below with it, because it doesn't have a negative exponent. It is just a negative number, like negative 7. All right, this is going to rewrite into 1 over 4 to the first minus 1 over 2 to the first. But having a first power really isn't necessary to write it, is it? So we'll get 1/4 minus 1/2. Make common denominators so they come together. So I'm just going to shift my 1/2 into fourths, calling it 2/4. So I get 1 minus 2 over the common 4 gives us negative 1/4. Negative exponents that begin in the bottom move to the top. So there's the rule that I just wrote down in pink. And I see a negative exponent in my denominator. This will shift to the top and become 4 to the third. On B, we're going to have the top moving to the bottom and the bottom moving to the top because they each have negative exponents. So they're each going to move in their position from numerator to denominator or vice versa. Let's see, we get 9 over 27. That will reduce. 9 goes into 27 3 times. So final answer, 1/3 on that one. Quotient rule, remember your quotient rule, or look back on the beginning of the lesson. We subtract those exponents. So this letter A is going to look like m to the top minus bottom, right? M is on top, m gets listed first. Top minus bottom, m to the negative 5. Now we're sitting with a negative exponent, so shift it from top into bottom position. It becomes a denominator. B, I can see a couple ways of dealing with this one. I think I would be tempted to move the negative exponents. Bottom going to top, top going to bottom. Then I would go into the quotient rule and get 5 squared. You could get the same answer, though, if you did top minus bottom exponent, keeping the negatives and not doing the shifting top to bottom like I did on the first part of the example. If I didn't do any shifting like we're suggesting here, it would be 5 to the negative 6 plus 8, which becomes 5 to the positive 2. Oh, it does work, doesn't it? We got the same answer. It just depends on, do you prefer working with positive exponents, or B, it didn't matter. You don't mind working with negative exponents, you're going to be fine going route B. Finally, C, I hope you're recognizing this. Look at those bases. Bases are different. So you cannot, no simplifying. possible. So that just is our answer. Only can pull them together if I'd had the same bases, like an x to the third over x to the fifth, right? Or maybe they were both y's, then we could pull it together. Alrighty, simplify using power rules. This is the rule where we have a power raised to another power, and we know that we should multiply those powers. So this is going to look like r to the 5 times 4, giving us an r to the 20. I would distribute that 2. Go ahead and draw those arrows. We'll make really nice notes for you. So I distributed those second powers to each term. And now I'm going to square negative 3, which would turn into positive 9. And y to the fifth raised to the power of 2 indicates that I will multiply 5 times 2. And there's our final answer, 9y to the 10th. For C, distribute that 3 to the denominator as well as the numerator. So I'm going to end up with 3 to the third over 4 to the third, which gives us 27 over 64. Express using positive exponents and then evaluate. All right, you've seen it before. Let's distribute, and we'll get 2 to the negative 4, 3 to the negative 4. Now, because of negative exponents, we're going to move. Bottom goes to top, top moves to bottom. And they said to evaluate this, 2 to the fourth, I know is 16. 3 to the fourth looks like 3 times 3 times, whoops, times 3 times 3. That makes 9 times 9. How about 81? That is 81/16. How many more pages? This is the last one, guys. I'm going to do power to power and multiply this up. Oops, let's show it this way. It gives me 4 to the negative 10th. And you're typically going to see rules where you cannot leave your answer with a negative exponent. So of course that drops it to the bottom because it was a top, it was a numerator value. So I get 1 over 4 to the 10th. Here I see bases are the same. So I'm going to add exponents. So this will make x to the negative 4 plus negative 6 plus 8. Adding those up, I'd have negative 4. Oh, no, it's not negative 14. Negative 10 plus 8. That negative 10 and positive 8 give me a negative 2. Write it using a positive exponent, so shift it to the bottom. And there's your answer. 1 over x squared. Oh boy, these get a little crazy, don't they? All right, I'm going to, whoops, didn't mean to do that. I'm going to distribute my negative 2 to each of those. And I'm just going to do that one step first. Negative 2 raised to the negative 2, m raised to the negative 2, over m negative 3n. Now let's move top and bottom. So this would be m to the negative 4. I'm going to shift it to the bottom. N to the second is going to move to the bottom. M to the negative 3 moves to the top. And n stays put because it has a positive 1 exponent. Now I've got 3 minus 4, don't I? I've got m to the 3 minus 4 over n to the 2 plus 1. Bases are the same, so we add exponents. Bring that together, I get m to the negative 1 over n to the third. Finally, no negative exponents allowed, so that'll shift to the bottom as a positive 1. Don't need to write anything. and then n to the third. There's our final answer. Notice how many steps I took, because I just wanted to be super careful about it. Distributed, first step. Multiplied that power to a power. And since it was negative, it dropped to the bottom. Negative exponent moved to the top. Negative exponent moved to the bottom. And then we just kept working through all those exponent rules. We used a variety of exponent rules. All right, last one. Let's distribute, distribute, distribute. So 2 to the second, y to the second. X to the third raised to the second. -1 goes to each and every term. So I'm going to get 4 to the -1, y to the -1, x to the -1. You can see there that everything is going to move on that second fraction. Top, bottom movement. All right, so we have, let's just expand 2 to the second, we know is 4. We get a y squared. The bottom becomes x to the 6 because we multiply them. I'm going to draw my fraction bar so I can move things top and bottom. 4 to the -1 drops to the bottom. Y to the -1 drops to the bottom. X to the -1 is bottom, so it moves to the top. All right, now we can rearrange. I'm going to alphabetically rearrange, and when I'm multiplying, numerators multiply numerators, denominators multiply denominators, and reorganize alphabetically. And now reduce. 4 goes into 4 one time. X to the first minus 6. And y to the second minus 1, right? 2 minus a power of 1. It's one way to do it. You might see, you might be thinking I'd do a little bit differently, and you're probably fine, because I can think of a couple other ways to do this. Let's just see if we get the same answer. My y stays on top because it had a positive exponent. X to the -5th drops to the bottom as x to the 5th underneath. That about wraps it up, you guys. Hopefully that wasn't too much review. Here is the homework. You can see right there. Doing just evens on all of these. You got a matching exercise here, another matching exercise there. Left column with right column. And hopefully you get that all written down. Have a great day.